Engineering, we study about computer networks because this is how we connect computers together to build very interesting applications and to have a better understanding of how computers communicate together. So, in our computer networks course, we are going to, our students study in a lab where they have hands-on experience with some computer network devices like routers and many other computer-related hardware. However, to also get a much deeper and more understanding, students can use computer simulators to simulate real network systems. Not only that, the simulator can also allow them to build many interesting applications without requiring them to be in the lab. So one very good example of such software is Packet Tracer. So uh, this is Packet Tracer. It's a free software designed by Cisco, which is one of the it's the largest company in the networking hardware manufacturing area. So this software you see is in fact used in many other courses in the COA department. For example, it's used to design networks in a computer designs course. It's also used in the IoT course to design IoT systems. And if you have not heard of what IoT is, it stands for the Internet of Things. So I'm going to show you one example of how this tool allows you to build realistic systems, uh, all at the comfort of your chair. So, and if you're using Packet Tracer, um, you can in fact drag and drop many devices. And if you see here, there are boards like prototyping boards or development boards like Arduino, Raspberry Pi. These are just models. You can do a lot of things with them. You can add even uh, network interfaces to them. You can add devices like hardware, computers, laptops, tablets, phones, and also network devices like routers and switches. So one simple example to see here is just to take a quick router. For example, this is the home gateway. It just resembles the router you have at home, the wireless router. So I can take a board, like you see here, MCU stands for microcontroller unit, SPC stands for a single board computer. So these are two different hardware. Uh, the SPC is more powerful, of course. It can run an operating system. And you see, but just by dragging and dropping this here, it just connected simply to the router. So if we um, look inside the board, you can see you can in fact play with many of its configurations. You can add network cards to it, like if you need an Ethernet or power adapter, wireless router, or even some cellular like 3 or 4G module, you can just drag and drop. And simply, you can change its configurations, name and IP address. You can even run applications on it, like you can run a web browser, or you can simulate if you're running a command prompt and you're running some commands in there to connect to other devices. So this is very powerful. You can even run programs on it, like we're going to show you how to use this to build a simple IoT application. So let's add more hardware or more components to our system. So you see here there are many kinds of sensors and actuators. Actuators are devices that you can control, like a light bulb, like a switch. You can show in a display, you can turn an alarm on and off, something like that. So I'm going to simply use an LED, which is a light bulb. Now you can connect this using simply a cable. So I'm going to connect it to the digital port 0 on the SPC, and if you click on this, it will show you that it only has one port called D0. So now they're connected. Now both of these run programs inside of them. So you can in fact look at the program that each one runs. Here you can see some information about the LED. It's dimmable, meaning you don't have to only turn it on and off. You can even use values in between if you want it to be at certain level of brightness. You can program it, as I said. For example, in fact, you can even add ports. So it has only one digital port. If you need more, you can add more if your application requires that. Now, for the programming part, I'm going to run the Python code, which is here. This is already there. So if I look at it, you can see how this is done. So simply, this is a program that reads value from certain port, and it's going to change how this LED looks. So suppose you would like to create something new, like you have a new device that does not exist. You can in fact just use images to show the different states, like this is when it's on, this is when it's off, and you put rules to which one goes at which time. Of course, this is done in the program here, and once you know that, you can develop very sophisticated applications. Now, something that question that may be in your mind is, if I do it here, this is not real. How do I use it? Well, first of all, this is mainly to build prototypes, to test your solutions if you have certain ideas. But it's also good to know that most of the code you use here can be easily ported to some other real platform. This looks very close to what exactly used in reality, in other words. So let's now go to this and try to run this code. So remember, this is connected to D0 on the board and D0 on the LED. So the board needs to set port 0 to high. In fact, if you know programming, this is nothing but an infinite loop. It comes here and it keeps doing this all over, forever, meaning. So I'm going to set the pin of 0 to out, meaning it's going to be an output port, and do this forever. Just set it to high, meaning at 1, in binary, which means on, and then turn it again to off. Okay, so set port 0 to high, set it to off, and between that we have just some delay, just to delay the operation, so we can at least see how it changes. Because if you don't add delays, it will switch on and off in a very fast manner that you won't be able to see the difference. Now the code is ready. If I just turn it on, it should start blinking, as you see. So this code is controlling the LED. In fact, you can make your code even more interesting by adding sensors. So sensors allow you to read some physical measurements, and using those measurements you can decide what to do. For example, you can see here there are many sensors. Some of them are for smart factories from the industry, some are for home use like in here, and some are for the smart grid, and many others. So for example, this is a trip sensor. What this is, it's basically two pieces with laser. So if you cross the laser, or a person crosses the laser, they're disconnected and they detect that there's an object in between. They're going to basically set off. So you can use this to control the LED. For example, when somebody enters the house, you can turn the lights on, and when he exits, or if there's nobody, you can turn the light off. So to do this, we can go here and change this. Now you'll notice it allows you even to use what we call smart device. So a smart device is a device that can connect directly to the internet, meaning it has Wi-Fi or Bluetooth built in, so it can connect to the router without the need for the development board. Now this is the default here. I'm going to set it to be no, meaning it has to go through the development board. So I need a digital port for it. That's what I'm going to add here. And if you in fact also go to the programming, you will notice that it has a program that tells it to also describe what it mainly does. So how do I connect this here? Simply again, just use the cable. I'm going to use the digital port 1. It will go to digital port 0. And since this has digital port 0, if you noticed in the code here, it uses digital port 1, so I'll change it to 0. Okay. So what this does is, when it is activated, it's going to set the output to high, and if it's not, it's going to set it to low. So that's how it detects when a person is or an object passes through the laser. So I'm going to run this. Now remember, this code does not read the data coming from there. So what I'll do is, what you need basically to do is read this the data coming from the trip sensor, and we will set the LED accordingly. So what I can say is, I'm going to read port 1, and I'll save the reading in a variable. And once I read this, I will set port 0 to the same variable. So if I read high, meaning somebody already passed, I'm gonna set the LED to the same value, and if it is 0, I'll set it again to the same value. So with this being ready, you can say run. So you can see the LED now is not responding because it reads 0 from the sensor. If I pass here, see, it has now it's triggered. If I move away, it's off. So you can see now you can build bigger systems, you can add more components to build more interesting applications. Now to show you some more advanced application, this is an example of a project that our students have done to simulate a smart garden or a smart farm. So you have multiple sprinklers, and they are reading the environment variables. So they read humidity, temperature, and some other parameters from the environment. And these are in fact available here. If you see, this describes the environment. There are many things you can in fact read, and once they read them, they can turn the sprinklers on and off. They also show some information on the display, and in fact this is connected to some machine learning and artificial intelligence in the background, which we also programmed outside this program, but we can connect, knowing how to do or join applications and make applications run together. So you can in fact build many other applications. So I hope that was informative, and hope to see you inshallah in another tutorial.